So basically, a vector, well, you've kind of seen vectors a little bit before, and so it won't be totally confusing, most likely. But if you imagine going from one place to another, let's say I'm traveling from this point in the bottom left, we'll call it point A, and we're traveling to point B. The direction and the length that you are traveling can be referred to as a vector. So we learn in physics that vectors have size and direction. As you can see, this line has a particular size, as in a length, and it also has a particular direction. So we can refer to that as a direction, as a vector. Now, one of the most important things you want to understand from vectors right from the get-go is that vectors have no specific location. So if, let's say that this was a particular angle to something or other, maybe 25 degrees, and the length was 5 centimeters, if somebody else traveled 5 centimeters at the same angle, it's completely true to say that it's the same vector. Okay, so it doesn't matter where it is. This vector is whatever vector it is. So what you can't do with the vector is you can't change the size of it or rotate it. Otherwise, it will no longer be that particular vector. So we can actually call these vectors particular names. Maybe we could call this vector V for vector. And it might have a little arrow over the top of it, just letting you know that it's a vector. Now, although you can't rotate it, if you can actually rotate it 180 degrees, but then you might guess that this is negative V.
Mm-hmm.
So again, we learn in physics that if something is moving at 5 meters per second, and then something else is moving in the opposite direction, also at 5 meters per second, we could say that this one is moving at negative 5 meters per second. So it's the same sort of principle in that way. Now, the next thing to understand about vectors is that you can represent them as a column vector. They're the same thing. It's just the way to understand it. So but they're just different ways of saying the same thing. So if, for example, I said it's 25 degrees, but rather than measuring an angle, I could measure the width of this vector. Maybe the width is, well, we could use a bit of Pythagoras here actually to work it out, couldn't we? Yeah. So this would be a right angle triangle because we're going horizontal and vertical. So therefore that would be a right angle. That's adjacent to the angle, and this is opposite the angle. The length of the vector would be the hypotenuse. So cos 25 would be equal to A over h. H is 5 centimeters. So therefore, I'll leave that there actually, and I'll say that A is going to be equal to 5 cos 25. I'm going to actually change the angle. I don't want it to be. I want it to be a nicer angle, so we're going to have to make it 60, because I think we'll find that the maths is going to be a lot easier then. Cos 60, I believe, is 0.5 degrees. I'm just going to double check that. I'm pretty sure it's cos. I'm 99% certain. Yeah, cos 60 is. I don't know what I just said there. Actually, I meant to say cos 60 is is 0.5. I'm not quite sure. I have a feeling I said something different there. But so cos 60 is a half, and so therefore A would be 2.5 centimeters, and then this one here, this one would be so. I guess A would be a different value, less, not a whole number perhaps. Let's see. So it's going to be this time it would be 5 sine 60. Yeah. So sine 60 is going to be a much more complicated number, but yeah. Okay, so I wonder if I can do. Oh, never mind. We'll just do it this way now. So five sine 60, and it's rounding up. It's 4.3 centimeters. So, in other words, the height of this vector is 4.3 centimeters, and the width of it is 2.5 centimeters. So, vector v could be represented as the width of it first, as in, so that's 2.5, and then over 4.3. To be honest with you don't normally do it as would usually use whole numbers, but yeah. And negative vector, negative v, would be the negative of both of those, because it's going, rather than going to the right and up, it's going down and left, like that.
Okay.
So, and you can see that we can see vectors kind of work in a very similar way to algebra. This is why you could put them in algebra or in geometry. So geometrically, we can understand the general idea of what a vector is, but they work algebraically as well. So we can see here that if we imagine this is just like any other algebraic value, negative v would be equal to negative 1 multiplied by v. And you can see that it is. So we just multiply the top number and the bottom number by the same, by negative 1, and it works. And the same would be true as if I doubled it or tripled it or halved it. I would do the same to the top and to the bottom number. So most of the questions are divided into these two different ways of thinking about them geometrically, or thinking about them in terms of numbers and column vectors. Occasionally what they'll do is combine the two ideas to check your deeper understanding of what vectors are. But if you have, I'll stop the video there. Maybe make a second video on some example questions.